Let's discuss question number 42. This is from test 2 from heat transfer. So a 2 kilowatt resistance heater wire whose thermal conductivity is given has a diameter so and so, length is given. So you have a resistance wire 2 kilowatt, so that is what is the power you are supplying, and the thermal conductivity value of the material is given as 15 watt per meter degree Celsius. The diameter is given as 4 mm, length is 0.5 meter and is heated to boil water, so just an electric heater. So outer surface temperature is 1 this is outer surface temperature. You want to find the center line temperature of the wire. So let me draw a cross section which is bigger. So this is your TS. I need to find T0 and this is your R0. Okay, now we have this is a classical standard problem from heat generation. When the heat is getting generated, now you are supplying power, the entire electric power input is converted into heat generation due to Ohm's law. Okay, so entire electric input is given to the heat generation. Now this heat generation, basically whatever heat is generated, that heats the water when you keep this in. So we have a derivation that on this now a cylinder where heat is getting generated, and the entire we have the steady state temperature distribution when the heat is getting in. So whatever heat is generated in this wire, that is again dissipated outside such that the internal energy of this wire remains same, or the wire attains a steady state. So in that case, the outer and the inner temperature are related like this. The inner temperature is outer temperature plus the heat generated per volume rate into the R square by 4K, where R is the radius of the wire. Now how do I find G naught? G naught is heat generated per unit volume. Now the total electric power is given to the heat. So the entire 2 kilowatt is the heat generated by unit volume is your pi R square into L. So heat generated is 2 kilowatt by your pi. Diameter is 4, so radius is 2 into length is 0.5. So let's use a calculator to calculate it. So this value comes out closer to your 0.318 into 10 power 9 watt per meter cube. So we need to just substitute this here to get your center line temperature T0. So TS is 105 plus G dot is your 0.318 into 10 power 9. R square is again 2 mm, so 0.002 by 4 into 15, which is your K. So this value once you calculate comes out closer to 126 degree Celsius. So the answer is 126, option is B. So this is again, this thing comes from the derivation for heat generation, heat getting generated and then radial heat transfer to attain a steady state temperature in a cylinder. So this is something which you need to know. Thank you.